This is week 11 problems, week 11 introductory activity, problem solving with formulas. Question 1. You deposit $6,000 into an account earning 3% interest compounded monthly. How much will you have in the account in 10 years? Since it uses the phrase interest compounded monthly, I'm using a compound interest formula, which is right here. Okay, my P is my principal, which is 6,000, and my interest rate here, interest is being applied at 3%, being applied monthly, so N is 12. The life of this particular formula is going to be 10, T for 10 years. So I wrote up my formula. So I wrote out my formula here. So I wrote out my formula. I assigned values to my variables in the formula. Then I plugged into the formula. I simplified it following the order of operations. So I'll start with what's in the parentheses there. So I simplified the exponent 12 times 10 to the 120th power. Then I can go ahead and focus on what's in here. So I have 0.03 divided by 12 plus 1. Doing what's following the order of operations. 103 divided by 12 plus 1, and I raise that to the 120th power. I multiply that by 6,000. And it gives me that value, $8,096.12, and that's what it should have there, but it cut off on the edge. And number 2, so review again. I wrote up my formula, I assigned values to my variables, then I plugged it into the formula, and then the fourth step here. I did my computation. Set it up completely first, then do your computation. So, and it doesn't always work out that you can follow the order of operations. Sometimes you got to do it in pieces when the formula is so big. I think I have one like that. Number 2. Meg borrows $200, agreeing to pay it back with 2% interest in 16 months. How much interest will she pay? So I'm using a simple interest formula here, where P is my principal, R is the rate at 2%, P is 200, and 2% is the decimal, 0.02. 16 months is times given in months. Convert that to a year, that would be 16 over 12 years. And I plug into my formula and I multiply here. Multiply everything and end up with $5.33 for number 2. Given the simple interest, linear growth of money model here, match the symbol with the functional notation with its meaning. In this case here, PRT, that's the interest. I is equal to PRT, remember that. Okay, this is 1 plus RT, that's the money growth factor. G is the 3, that is a money growth. M here is growing, so it could be the future value of it all. T is time, R is the rate, and P is the present value of it. True or false if T is in years but interest rate is 1% monthly. Then R is equal to 0.12. Okay. So the interest rate is 1% monthly. Then for the year it's going to be what? 0.12. That's a true statement. So it's a monthly interest rate of 1%. The total interest rate for the year is going to be 0.12, and that's a true statement. Number 4, ask you to do that again. Okay. In this case, V, number 1 there, V is the present value. 2 here, B is the money growth, and then 3 here is time. There's 0 underneath it. You can identify what it is. 4, H is the future value. Okay. 6 here. You can factor that out, and now you have that money growth factor. And 7 here is the interest, I is equal to PRT. Principal is the same as future value. They are not the same. That's a false statement. Part B, you need a simple interest bridge loan to cover costs of buying a new home while waiting to close on your old one. You need to finance $50,000 and a bank will charge 9%. How much interest will you pay if you need the loan for 7 months? Okay. I'm using a simple interest formula here. I'm obviously going to PRT, where P, the amount of finance is $50,000. Interest rate being charged is 9% at 0.09 in 7 months. So T would be in the years would be 7 over 12. So when I multiply this out, it gives me the amount of interest, which is $2,625, which goes there. So in this case here, write out your formula. And then you assign values to your variables in the formula. And then 3, you plug into your formula. And then there's your computation there. So I wrote out my formula, assigned values to the variables in the formula, and then I plugged into the formula, and then I did my computation. Your friend needs a loan of $4,300 in 5 months. You tell him simple interest on a loan service needs to pay you back $443. What is the simple interest rate? They want the rate here. So simple interest rate, I have my formula here, and I solve it for R. So there's my formula here. I solved it for R. Okay. And I can plug in. Solve for R here. In this case, my R is 8%. Approximately 8%. So for the first part there, you have to find, right out my formula, you're going to need to find I. So my I can be found here. So wrote out my formula, assign values to the variables in the formula. I is the difference in the amount of interest here. You have the future value, you have the starting value, the amount of interest is 143. That's my I. My principal here, starting value is 4,300, and T is 5 over 12 years. So I have my formula here. I wrote out, assign values to the variables in the formula, and then I plug into the formula. And then I do my computation. So write out your formula. Assign values to the variables in the formula. And then you plug into the formula. And then you simplify. Okay. Fatuma invests $20,000 at 13% simple interest for a year. How much is in the account? What is the future value after 1 year? So the future value is A, P, the principal starting value, the amount of interest there. That's, we have to find that. So just simple interest formula, I is equal to PRT. So I have my formulas here I'll be using. And I have to find the interest. So assign values to my variables in the formula. And then I plug into the formula. And I simplify it here. My I is 400. My I is $2,600. So my future value, I have my formula there. I know what I is, I know what P is here, and I plug into my formula, and then I do my computation. I have my formula there. So I already assigned values to the variables. It's already been done. So I can plug in. And the last step there is you do your computation. So your final answer is $22,600. Number 6, you want to buy a $247,000 home. You plan to pay 15% as a down payment and take out a 30-year loan at 5.4% interest for the rest. How much is the loan amount going to be? You got to figure that part out there. So assuming that you have the 15%, you have to find that. So the amount of the down payment is going to be 15.15 times the amount of the loan. So 15% of that is $37,050. Okay. So the loan amount is going to be the difference between the home cost and the down payment. So 247 minus 37,000 gives me $209,950, which goes there. What would the monthly payments be using this formula here? We already know what our principal is. We know what our rate is here. And the monthly payments in is 12 divided by 1 minus 1 plus R of N. So we know what the rate is 0.054. It's from there. And N is 12 monthly payments. And you have here NT. N is 12 and T is 30 years. So we apply this formula here. Now for this particular problem here, when you go to simplify it, you're going to simplify your numerator first and then simplify the denominator and then you're just going to divide, and it'll give you this answer here. Okay. Okay. So you have your payments there. So in this first one here, when they ask how much do you total, what's the amount being repaid, you can go down here and find that. So we have here the total repaid. Monthly payment times 12 times the number of years. We have the monthly payment times 12 times the number of years. Okay. And that's 30 years there, so $424,000. $414.80. That's the total repaid. All right. And then how much is interest? So you have the total repaid minus the amount of the loan. So the total repaid minus the amount of the loan is going to be $200. Total interest is $214,464.80. So that goes there. Okay. Then they want you to do the same thing again with different numbers. Suppose you want to pay off the loan in 15 years instead of 30. What is your monthly payment going to be? So you use the same formula, except in this case here, and T is going to be 15 instead of 30. So you use the same formula, except T is going to be 15. In this case, the amount of the payment is $1,704. How much interest you save would be the difference. Okay, so down here, so the total repaid here, monthly payment times 12 times 15, you end up paying $306,783. So the total savings is going to be total repaid at 30 minus total repaid at 15, which is $117,631.80. And that goes right up there. That's how you do that problem. And that takes care of that. And keep going. This is number 7 here. So on this one here, you want to buy a $220,000 loan. You make a 15% down payment. You take out a 30-year loan at 4.35% interest. What is the amount of the down payment? 15% of the $220,000, which is $33,000. What is the amount of the mortgage? This is the difference between the cost of the house and the amount you put on it. So you're financing $187,000. Points on the loan. These are charge-offs that you can do on a loan at the very beginning. Each point is 1% of the loan. And so in this case here, the amount that you're financing is 180, so be 3% of 187,000 is $5,610. Question 8. Okay. JC and Zari want to buy a $90,000 home. You make a 5% down payment and take out a 30-year loan at 5.15% interest for the balance. How much is the loan going to be? So you got the amount of the down payment. Okay. So in this case, it's 5% down. 5% of 190,000 is $9,500. And so the amount of the loan is going to be the difference between the home cost and the down payment. So 190,000 minus 9,500 gives me $180,500. That's the amount of their financing. So what will the monthly payment be? So use this formula here for your monthly payment, and you plug into it here. And the amount of the monthly payment is $985.58. So the next one here, how much is go up to the other part, how much of the first payment is interest? So that's number 8. Okay. Amount of interest in the first payment here. So the amount of interest in the first payment is right there, $774.65. So you put that in. What is the total amount of payments? So we know the payments there, and you know the life of the loan, and it's 12 months in a year. So the monthly payments is there times 12 times the number of years. So that's the total amount being repaid. Okay, and the total interest is the difference between the total repaid and the life of the loan, which is $174,000. Okay, and that's how they got those two values. Number 9. The final amount of money in the account. Find the final amount of the money account if $6,700 is deposited at 3% interest compounded quarterly every 3 months, and the money is left for 9 years. So it's a compound interest formula here. There's my compound interest formula. I assign values to my variables here, and I plug in. Okay, the final amount, the future value is $8,767.92 there. Don't forget that you got to multiply that exponent. The exponent here, 4 times 9. So everything is going to be raised to the 36th power. Number 10. A bank features a savings account that has an annual percentage rate of 5.1% with interest compounded semi-annually. K-Sucker deposits $4,000 into the account. The account balance can be modeled by the expenditure formula given there, where S is the future value, P is the present value, R is the percentage rate, N is the number of times each year interest is being applied, and T is the time in years. So what values should we use for P, R, and N? So P is 4,000, the rate is 5%, so that's a decimal 0.05, and T they're saying T is 2 years here. Okay. Okay. The phrase there, semi-annually, that means interest is being applied twice in a year, so N is equal to 2. Alright. In this case, you apply the formula, you end up with $6,618.71. And then they say round to the nearest penny. P here. What is the annual percentage yield? Okay. So you know what your R is, and you see the formula there. And if it doesn't give it to the formula, there it is here. You know what your rate is, you know what N is, and you plug in and find the formula. The annual percentage yield. Number 11. It's another one like it. Okay. Number 12. It's another one like it. What's different in these? What is different in each one of these problems is N. In the first one, N is 2. And the next one, N is 4. And this last one here, N is 52. Okay. And number 13, you deposit $5,000 into an account earning 5% interest compounded monthly. What is the future value? How much will you have in the account in 5 years? So you can see what P is. P is 5,000. My R is 5%. It's a decimal 0.05. Compounded monthly, N is 12, and life of it is 5. T is 5. So you plug into your formula. Don't forget that everything here, you have to multiply this 12 times 5, which is going to be what, 60. So everything is being raised to the 60th power. So all of this is being raised to the 60th power. And your future value is $6,416.79. And that is the end of that particular part.